In August 2012, employees at Saudi Aramco, one of the world's most critical energy companies, arrived for a standard workday in Riyadh. When they sat down at their desks, they discovered their computer screens were blank. This was happening across the entire company. 30,000 corporate workstations had simultaneously gone dark. Typically, a massive corporate hack involves quiet espionage. An attacker breaches the system, remains invisible, and slowly extracts valuable data, like emails, passwords, and trade secrets over months or years. The malware inside Saudi Aramco, known as Shamoon, was engineered for something else entirely. Its objective was visible destruction. The code was specifically designed to overwrite data on infected machines, permanently corrupting the files and turning the hardware into unusable bricks. Yet, while the corporate headquarters was paralyzed, the heavy industrial machinery outside kept running. The oil pump jacks continued moving. The physical flow of global energy never paused. How could a cyber attack entirely erase a global corporation's digital footprint without halting a single drop of oil? The answer exposes the hidden boundaries inside the systems we rely on every day. This diagram illustrates a modern corporate network. Large organizations run on shared infrastructure where thousands of endpoints constantly exchange information. That same connectivity creates a severe vulnerability known as a blast radius. If malicious software enters, the infection can spread instantly. Shamoon weaponized this exact architecture. It jumped from its initial entry point and multiplied so rapidly that it wiped out 30,000 machines before human administrators had time to physically pull the network cables. The attack eventually stopped because of network segregation. Cybersecurity relies on strict boundaries between different types of systems. Information technology, or IT, manages business data. Operational technology, or OT, controls physical industrial processes like water treatment, manufacturing, and power generation. Shamoon destroyed the IT layer, erasing emails and financial records, but it hit a structural wall before it could cross over to the OT layer. The systems managing the physical oil production were insulated from the corporate network. Separating those two networks prevented a global catastrophe. If that boundary had failed, the malware could have reached the industrial controllers, bringing one of the world's largest energy supplies to a dead stop. Without corporate computers, Saudi Aramco employees had to run a massive global logistics operation using typewriters, fax machines, and paper records. Destructive malware creates extreme asymmetry. An attacker writes a small amount of code for almost nothing. The victim is forced into a grueling physical recovery, throwing away ruined hardware and purchasing thousands of replacement parts. You cannot simply hit a restore button when you no longer trust the network holding your backups. Rebuilding requires administrators to manually verify which parts of the infrastructure are clean and which have been compromised. Technicians flew in replacement hard drives, validated clean software completely offline, reconnected 30,000 separate endpoints to ensure the infection was gone. Surviving a digital wipeout translates into an enormous physical supply chain operation. Erased data demands shipping crates, replacement parts, and countless hours of human labor. This incident proved that a company's corporate network acts as the information layer holding its physical machinery together. You do not need to blow up an oil pipe to cause extreme operational pain. You can simply destroy the scheduling and procurement systems that tell the pipe when to open. That explains why attackers choose loud destruction over quiet espionage. Erasing thousands of workstations sends a geopolitical message. It is a highly visible demonstration of capability and vulnerability. State-linked actors deploy these tactics to exert pressure across borders. They can force massive economic disruption and organizational chaos thousands of miles away, all without deploying a single soldier or conventional weapon. Paralyzing a global institution's digital nervous system accomplishes a powerful strategic goal. It proves to the world that you can cripple an adversary from the inside. Protecting modern infrastructure requires acknowledging a difficult reality. In a hyper-connected global economy, assuming your firewall will block absolutely every attack is mathematically impossible. This diagram shows cybersecurity's modern mandate: resilience. Assuming an attacker will eventually breach the perimeter, we cannot build brittle walls that shatter. systems must be designed for rapid containment. When a node fails, it is instantly isolated, purged, and rebuilt from protected offline backups. When critical industries run entirely on digital infrastructure, true security is about designing systems so that an inevitable failure never spirals into a fatal catastrophe.